Is going to summarize the idea from topic 7, air and living things. So we first of all talk about the composition of air. So in air, it's actually a mixture of different gases. We have got nitrogen, oxygen, carbon dioxide, noble gas, argon, etc. So for these gases, we have nitrogen got most abundance, and then we have got oxygen, and then we have got some other gas, and carbon dioxide only occupy 0.04%. And then it's about how do we tax different kind of gases, like for oxygen gas, it can relight a glowing spleen. For carbon dioxide, it can turn lime water milky, or it can turn hydrogen carbonate indicator from red to yellow. And please notice that the hydrogen carbonate indicator is actually help to indicate the percentage of carbon dioxide in air. So if it will show different color based on different percentage of the carbon dioxide. For example, if it is very abundant, let's say more than 0.04%, then it will show yellow. But in room condition, let's say in air, with carbon dioxide in 0.04%, it will be in red color. And if it's less, then it will become purple. And then for water vapor, I can turn a dry cobalt chloride paper from blue to pink. And it comes to respiration, so which is a energy conversion, which help to transfer or convert different kind of energy into other form of energy. Like while we're eating hamburger, how do we convert the chemical energy of hamburger into other form of energy, like the sun energy, like while I'm talking. And so for this process is what we call respiration. And for respiration is actually a chemical reaction that make the oxygen and food and then convert into carbon dioxide, water, and also other form of energy. And it plays inside the cells. And for photosynthesis, it's actually a reverse of respiration. Okay, we have got a word equation like carbon dioxide plus water become oxygen and glucose. And some condition is necessary. It must have light, carbon dioxide, water, and also most important is about chlorophyll. That's why human cannot carry out photosynthesis because we don't have chlorophyll in our cell. But for green plants, why they're green? Because they have got the chlorophyll. And the chlorophyll actually make a green color, and this actually help them to absorb the light and trigger this photosynthetic reaction. And the glucose being produced will then be converted into starch for the storage. And for experimental design of photosynthesis, if we want to show some factors is necessary for photosynthesis, we must carry out a process called destarching, which is to keep the green plants in dark for 1 to 2 days to ensure that all the starch in the plant is already consumed before the experiment. And hence, we can conclude that any starch produced after the experiment, those starch produced is really made during the experiment, but not that presence at the beginning. And then it's about using sodium hydrogen carbonate is actually have to provide carbon dioxide for photosynthesis, and for soda lime is to absorb carbon dioxide. And we do also have an experiment to test different products of photosynthesis, like testing starch. If for starch, it can turn iodine solution. It must be iodine solution rather than just iodine, from brown to purple. So for this process, it's actually with 4 steps, like boil the leaf in water, heat the leaf with hot alcohol, and wash the leaf, and also add the iodine, so on and so forth. And when you take a look at this diagram, you may pay attention for this part, is that the Bunsen burner is closed when the flame when we heat it with hot alcohol, and then we make sure that the Bunsen burner is closed at that moment, because alcohol is volatile, it's easily to evaporate, and the they are very flammable. If we heat it up directly, then the alcohol may be on fire. So it's going to be some safety precaution whenever we carry out this experiment. And then it's about if you don't test starch, we can also suggest another way to test products of photosynthesis, which is oxygen. That we can use this method, what we call water displacement method. That at the beginning we fill up the conical, no, the filter funnel, the inverter filter funnel, and also the test tube, all with water, and then the gas is actually produced here, and then it displaces the water, and so that we can collect the oxygen gas, and we can make sure that these gas is actually produced from the plants rather than those gas already present there. And for oxygen, it can actually relight a glowing flame. And for oxygen, it can that relight glowing flame. This is how we test oxygen. And then for the gas exchange inhalement, is that we've got breathe and unbreathe air, and then for different kind of gases, we have like this. And please note that even though for breathe air have higher percentage of carbon dioxide than unbreathed air, but still carbon dioxide is just very low. Okay, so even though some gases is being consumed and produced through the process, nitrogen is still the highest, is still the most abundant gas in breathed and unbreathed air. And it's about the breathing system. So breathing system is actually different from respiration. Breathing system is actually just a way how do we um, gain the oxygen and how can we breathe out carbon dioxide. It's nothing to do with the energy conversion. So for the energy conversion, it's actually about respiration, which is a chemical reaction. But then for breathing, it's just a physical process that how we can obtain the desired gas. So all this function, okay, the nose and the trachea and the lung, and inside the lung we've got the air sac, and the air sac is actually where the gas exchange occur, that the oxygen will dissolve in the layers, the watery layer of the air sac, and then will diffuse into the blood, or technically it's the red blood cell in the blood. And then the carbon dioxide from the red blood cell will also diffuse back to the air sac. Breathing in and breathing out. So the mechanism of breathing in and breathing out, in a way, how do we get oxygen to our body and how can we remove oxygen out of our body? So we got a process like this. So yeah, just notice that even for breathe out air, there's still oxygen. We will not fully consume the oxygen. So just talk about breathe in air and breathe out air. Okay, how do we do it? So we have a process called exhalation and inhalation. So I'll just talk about exhalation, which is the reverse of inhalation. So to think about the mechanism, I normally start from the last part. It's like if for exhalation that the air is breathed out, it means that the pressure inside our body is greater than the atmospheric pressure, such that the air is breathed out. And if we think about why the pressure inside our body is greater, because the volume of the thoracic cavity decrease, it makes the pressure inside the body increase. And why the volume of the thoracic cavity decrease? It is because the intercostal muscle relax, it makes the ribs move inwards and downwards, and also the diaphragm muscle relax, it makes the diaphragm become dome shaped. So these two changes can help to reduce the volume of thoracic cavity, and somehow it can make the pressure increase. And when the pressure inside the body is greater than pressure outside the body, then we can breathe out the air. So this is how breathing mechanism is work. And for gas exchange in plants, this is more complicated because both respiration and photosynthesis take place during the daytime. and the rate of photosynthesis is greater than the rate of respiration if it is at noon. So let's say if it's very shiny, and and then it will have situation that photosynthesis is very fast, and that the rate of respiration is just normal. Okay, and then we can say that by this process that the photosynthesis will take place faster than the rate of respiration. And in terms of the gas exchange, that's because photosynthesis will consume carbon dioxide, and rate of respiration will consume oxygen, right? So for this process will make carbon dioxide absorb and oxygen is released. And why these two processes will happen at the same time for plants during daytime? Because they're actually two different reactions. With respiration is actually a process that how can we change the food into other form of energy. And for photosynthesis, it's like how do we make the food? So which is a two very different process, and if these two processes happen together, it depends on the light intensity to have different changes of the rate, and then it will also affect the net amount of the carbon dioxide and also the oxygen gas absorbed or produced. And in nighttime is rather easy because there's only respiration take place. There's no light, and that's why photosynthesis cannot take place. And for this part, carbon dioxide is released. So just based on the light intensity, the rate of photosynthesis and the rate of respiration can be very different, and this will also affect the carbon dioxide uptake and also the carbon dioxide produced. So let's take a look for this diagram. So at here you can see the night, day, and also the night. It means the light intensity. So at the middle here is probably like noon at 12. Then it should be the most shiny, and then the rate of photosynthesis is much faster than the rate of respiration. And then the carbon dioxide uptake is very high. So meaning that carbon dioxide is being consumed and oxygen is being mainly produced here. And you can see there's 2 point called light compensation points, which is a point where the photosynthesis and respiration are of the equal rate. And for the nighttime, you can see here, if there's no light, no photosynthesis, then only respiration take place. But for nighttime, it will not quickly become no lights, right? It will gradually become less light, and eventually totally dark. Okay, and this is how we see the graph in a continuum manner. And for this process, we'll make the balance of oxygen and carbon dioxide. If we have got enough plants, then actually the atmospheric air will actually strike a balance between oxygen and carbon dioxide gas. So because for photosynthesis we produce oxygen, and oxygen is consumed by respiration to produce back carbon dioxide, and carbon dioxide is also be consumed by photosynthesis. So somehow this is actually like a balance. We do have a constant amount of oxygen and carbon dioxide gas in the atmosphere. But if this balance is broken by deforestation or like burning fossil fuel, then there will be too much carbon dioxide produced. And it will actually cause some environmental problem like global warming, and then or like ocean acidification. So why ocean acidification take place? Because carbon dioxide gas, when it is dissolved in water, it is acidic, and then it will actually change the pH value of the ocean, and then the fish inside inside the sea may get affected, and also it will cause some abnormal growth of plants. So that's it.